Welcome to the deep dive. We sift through the sources, find those key insights, basically giving you the shortcut to getting up to speed. Today, we're tackling something everyone wants, but, well, finds tricky. Happiness. I mean, how do you even pin it down? It's different for everyone, kind of elusive, really hard to measure. And yet there's this one molecule, serotonin, that seems to have this like iron grip on the popular imagination as the happiness hormone. You search online and boom, there it is. But, is that really the whole story? Is serotonin truly the hormone of happiness, or is that maybe just, I don't know, great marketing? And maybe more importantly, what else is serotonin doing in our bodies?
Yeah.
So we're going to deep dive into today, really pull back the curtain on this surprisingly busy molecule.
Yeah, it's fascinating, isn't it, how something we link so strongly to just one feeling, happiness, actually has this huge, varied job description throughout the entire body. We'll definitely unpack that popular idea first and then look at the much bigger and honestly more surprising picture.
Okay, let's get into it. Serotonin. Okay, the chemical name is 5-hydroxytryptamine, right? 5-HT. But it's not just doing one job, is it? It sort of wears two hats.
Exactly, it's both. It's a really important neurotransmitter, so it's passing signals between nerves in the brain, but it also acts like a hormone, sending messages all around the body, way beyond the brain. That dual role is why you hear it called both things, because, well, it really does function in both systems, brain and body.
Right. So let's start where most people think of it, the brain. Given its reputation, what are its main jobs, sort of, in our central nervous system?
Well, in the brain, serotonin is incredibly versatile. It helps manage our body temperature. It affects our appetite, whether you feel hungry or full. It plays a big part in memory and learning. It's also really key for regulating sleep cycles. It can actually help you fall asleep and help you wake up. And yes, it definitely influences sexual behavior, can increase desire, and crucially, it helps regulate our mood. That's the big one people know.
Okay, and this is where it gets interesting for me. I've heard certain drugs, they kind of mess with serotonin, right?
Yes, that's true. It's a sort of curious detail, but some drugs, think ecstasy or LSD, they directly interfere with how serotonin works in the brain. And that interference causes effects like reduced appetite, increased sex drive, feelings of euphoria, sometimes even hallucinations. Shows you how powerful it is.
So, okay, connecting this back to mood and happiness, what's the mechanism there, and does it influence that feeling?
In very simple terms, serotonin helps us register how satisfied our basic needs are. So when you've got enough food, water, sleep, generally your serotonin levels tend to be higher. And that correlates with feeling, well, more content, maybe happier. And the reverse happens when those basic needs aren't met. Levels tend to dip.
Okay, and is that why low serotonin often gets mentioned alongside things like depression or anxiety?
Precisely, yeah. Lower levels of serotonin in the body have been linked, associated with conditions like depression, anxiety disorders, OCD, which is why, a major class of medications for these conditions, the SSRIs, selective serotonin reuptake inhibitors, they work by essentially boosting serotonin activity in the brain. But, and this is really important, while serotonin is definitely involved, its exact role in these very complex conditions is still, well, debated. It's a bit controversial. There's a lot of discussion about whether low serotonin is the cause or just a symptom, and if targeting only serotonin is always the best approach. There's still so much we don't know. It's definitely not as straightforward as low serotonin equals depression.
Right, not a simple equation.
Okay.
Okay, but you said earlier the brain is just the tip of the iceberg. So what's the big surprise? Where's most of this stuff actually found?
Get this. An estimated 90%, 90, of the body's serotonin isn't in the brain at all. It's in our gut. In our intestines.
The 90% in the gut. How does that even work? That seems backwards somehow.
It does sound counterintuitive, doesn't it? But it's stored in these special cells lining the intestine. They're called enterochromaffin cells. And when these cells sense food arriving in your stomach, after you've eaten something substantial, they release serotonin. And this gut serotonin does two main things. It helps dial down your appetite so you don't just keep eating forever. And it triggers movements and secretions in the intestine to help you actually digest the food. Pretty crucial. And connecting that thought, changes in how this gut serotonin works, are thought to play a role in things like irritable bowel syndrome, IBS, that condition causing pain, bloating, gas, and either constipation or diarrhea. The thinking is maybe lower serotonin slows things down, causing constipation-type IBS, while higher levels might speed things up, causing diarrhea type. Though I have to stress, it's really complex, and researchers are still figuring out the exact mechanisms.
Okay, wow, so digestion makes sense given it's in the gut. But are there other jobs it does that are even more, well, unexpected?
Oh, yeah. There's a particularly curious one, vomiting. Serotonin is involved there too. So if you eat something bad, something spoiled, those same gut cells, the enterochromaffin cells, they release even more serotonin. This makes your intestines contract faster, try to get rid of the toxin quickly, diarrhea. But if the serotonin release is really big, like too much for the gut system to handle, the excess spills into the bloodstream. It travels up to the brainstem, hits the vomiting center, and boom, triggers vomiting to expel the stuff from the top end too.
Huh. So those medicines you take to stop feeling sick, some of them might actually be blocking serotonin.
Exactly. Yes. Some anti-nausea, antiemetic drugs work precisely by blocking certain serotonin receptors involved in that vomiting reflex.
Okay, that's one surprise. What about blood? You mentioned blood earlier. That seems like a totally different area.
It does, right? But here's the thing. Some of that serotonin released in the gut actually gets soaked up by blood platelets. Those little cell fragments floating around that help your blood clot when you get a cut? So when you get injured and there's bleeding, the serotonin stored in those platelets springs into action. It does two key things. It makes the platelets clump together, helping to form a clot, and it causes vasoconstriction. It makes the blood vessels nearby squeeze tighter, narrowing them to reduce blood flow to the injured spot. Basically, it helps stop you from bleeding out. It keeps your blood where it should be.
That's incredibly important and completely unexpected, and I heard the name itself relates to this.
It does, yeah. It's a neat bit of trivia. This blood vessel function is actually where the name serotonin comes from. It's derived from Latin serum, meaning blood serum, and Greek tonos, meaning tone, like muscle tone. It was first identified as a substance in blood serum that affected the tone of blood vessels, hence serotonin. So there you go. You won't go to bed tonight without learning something new.
Definitely not. Okay, so mood, sleep, appetite, digestion, vomiting, blood clotting. How? How can one molecule be involved in so much seemingly unrelated stuff? It feels like, I don't know, biological magic.
It does seem like magic, but it's actually down to molecular specificity. The real answer is receptors. Our bodies have many different types of serotonin receptors. We know of at least 14 distinct subtypes, maybe more. You can think of them like different kinds of switches or maybe locks. Serotonin is the key. But the effect of turning that key depends entirely on which lock it fits into and where that lock is located. So if serotonin binds to a certain receptor type in the brain, it might affect mood or appetite or sleep. But if it binds to a different receptor type in your gut, it influences digestion. Or if it binds to receptors on platelets or blood vessels, it affects clotting and blood flow. It's this combination of different receptor subtypes located in different parts of the body that allows this single molecule to have such incredibly diverse functions. Location, location, location.
Okay, that makes sense. It's the context, the receptor that matters.
Right.
So let's bring it all back. Our original question. Is serotonin the hormone of happiness? What's the verdict?
Well, look, we've seen it absolutely plays a role in regulating mood. It contributes to that feeling of well-being, especially when our basic needs are met, no doubt about that. But calling it the happiness hormone, that's just a massive oversimplification. It really is. When you factor in its vital jobs and, stopping bleeding, making your gut work, managing appetite, even making you vomit, calling it just the happiness hormone totally misses the bigger picture. You could just as accurately call it the blood clotting hormone, or maybe less appealingly, the vomit hormone. But I guess those wouldn't catch on, would they?
Probably not. And happiness itself, that's got to be way more complicated than just one chemical floating around, right?
Oh, absolutely. Happiness is profoundly complex. It involves countless other hormones, neurotransmitters like dopamine, endorphins, intricate brain circuits, our life experiences, our thoughts. Trying to pin it all on serotonin just doesn't do justice to the sheer complexity of human physiology and, well, the human experience.
So wrapping this up, what's the main takeaway for you listening right now?
I think the main thing is that the human body is just this incredibly intricate, interconnected system. Molecules like serotonin wear many, many hats. So be skeptical of those simple, catchy labels. The happiness hormone, the love molecule. They make good headlines, but the reality is always much richer, much more nuanced. Understanding that complexity is, I think, much more empowering in the long run.
Yeah, it definitely makes you think twice about searching for single magic bullet solutions. Okay, so here's a final thought for you to chew on. Thinking about all these connections, how serotonin links mood to gut health, to even blood clotting. How might really understanding these interconnected systems, instead of just focusing on single molecules or symptoms, change how we approach our own health and well-being? Something to think about.